Today we're diving into a paper that explores a new approach to personalizing large language models, LLMs, on device. The paper, Adaptive Self-Supervised Learning Strategies for Dynamic On-Device LLM Personalization, proposes a framework called ASLS. What are the main challenges that ASLS addresses?
The paper highlights two key challenges. First, traditional LLM personalization methods often rely heavily on labeled datasets, which can be expensive and time-consuming to create. Second, these methods typically involve batch training, which can be inefficient for dynamic on-device personalization, where user preferences can change rapidly. ASLS aims to address these challenges by leveraging self-supervised learning and continuous adaptation.
Can you elaborate on how ASLS utilizes self-supervised learning?
ASLS employs a two-layer architecture. The first layer is a user profiling layer that gathers interaction data from the user, such as their feedback, interaction frequency, and contextual information. This data is then used to create a user profile that captures their preferences. The second layer is a neural adaptation layer that dynamically fine-tunes the LLM based on the user profile. This fine-tuning process is self-supervised because it doesn't require labeled data. Instead, it learns from the user's interactions with the model.
So ASLS essentially learns from the user's behavior to personalize the LLM. How does this continuous adaptation work in practice?
The neural adaptation layer continuously updates the LLM's parameters based on the user profile. This means that the model is constantly learning and adapting to the user's evolving preferences. The paper emphasizes that this continuous adaptation is crucial for dynamic on-device personalization, as it allows the model to respond to changes in user behavior in real time.
It's interesting. How does ASLS ensure that the model adapts efficiently without requiring excessive computational resources?
ASLS incorporates adaptive mechanisms that minimize the computational overhead associated with personalization. The paper highlights that these mechanisms are particularly important for on-device applications where computational resources are often limited. The authors claim that ASLS can achieve significant personalization gains with minimal computational cost.
Can you provide some specific examples of how ASLS adapts the LLM based on user interactions?
The paper doesn't provide specific examples of adaptation strategies. However, it mentions that the user profiling layer captures various aspects of user behavior, including feedback signals, interaction frequency, and contextual information. This suggests that ASLS can adapt the LLM based on factors such as the user's preferred response style, the topics they are interested in, and the context of their interactions.
The paper mentions that ASLS was evaluated across various user scenarios. What were the key findings of these experiments?
The experiments demonstrated that ASLS significantly outperformed traditional personalization methods across multiple datasets and user scenarios. The paper reports that ASLS achieved higher user engagement and satisfaction scores, indicating that the model was able to generate more relevant and appealing responses.
That's promising. Can you elaborate on the specific metrics used to evaluate user engagement and satisfaction?
The paper doesn't provide detailed information about the specific metrics used. However, it mentions that the experiments involved measuring user engagement and satisfaction levels. This suggests that the authors likely used metrics such as click-through rates, time spent interacting with the model, and user feedback surveys.
The paper also conducted ablation studies to assess the contributions of different components within ASLS. What were the key takeaways from these studies?
The ablation studies revealed that both the user profiling layer and the neural adaptation layer are crucial for ASLS's performance. The paper found that using only one of these components resulted in lower performance compared to using both. This highlights the importance of a comprehensive approach that combines user profiling with dynamic model adaptation.
The paper also explores different user feedback collection methods. Can you summarize the key findings in this area?
The paper compares 5 different feedback collection methods: active feedback collection, passive observation, surveys, implicit feedback mechanisms, and personalized suggestions. The results indicate that active feedback collection and personalized suggestions lead to the highest user engagement and satisfaction scores. This suggests that methods that actively solicit user feedback or provide personalized content are more effective in capturing user preferences.
The paper acknowledges that ASLS has some limitations. What are the main challenges that need to be addressed in future research?
The paper identifies two main limitations. First, ASLS relies on user interaction data, which may not be sufficient if the user doesn't frequently engage with the model. This could hinder the personalization process. Second, the effectiveness of the neural adaptation layer can vary based on the diversity of user interactions. Limited data diversity may lead to suboptimal performance.
How can these limitations be addressed in future research?
Future research could focus on developing more robust data collection methods that can capture user preferences even with limited interactions. Additionally, researchers could explore techniques for enhancing data diversity to improve the effectiveness of the neural adaptation layer.
The paper also discusses the potential for using reinforcement learning to further enhance ASLS. Can you elaborate on this aspect?
The paper suggests that reinforcement learning could be used to fine-tune the personalization process. This could involve training the model to maximize user engagement and satisfaction by rewarding it for generating responses that align with user preferences.
This was a fascinating discussion on the technical aspects of